educators. We are deeply honored to have Mr. Narayana Murthy, founder of Infosys, Professor Paul Hewitt, who has joined us virtually, literally at 4:30 a.m. his time. Thank you, sir, for joining. Thank you, Dinesh, sir. You have made it up today. Thank you so much for being here. Thank you all for joining this day today for the launch of Conceptual Physics 13th edition by internationally acclaimed author Professor Paul Hewitt. Just to set a context, a couple of weeks back I was in a conference and few students joined me, reached out to me asking, sir, we are finishing the CA final course. We are sure we'll pass this time, but what additional skills do I have to acquire to be employed when we finish qualifications? Ladies and gentlemen, 20 years back when I qualified, that was good enough to find a job. The world is rapidly changing. People, the requirements of skills apart from the normal qualification is increasing day by day. It's imperative that students, today's learners have right knowledge, right skill sets, so that they can thrive through the global competitive landscape today. India is poised to be a Viksit Bharat by 2047. Let's just remind ourselves, it's just 23 years from now. It's not too far. The transformation for this has already begun. Higher education sector, across all sectors, and higher education sector is also transforming itself. Students are learning has become engagement, and people are looking for engaged learning services. Passive consumption of the resources has now moved to active engagement of it. People want to experiential learning is gaining knowledge. Pearson is at the forefront of this transformation. We are innovating to cater to these requirements. If we look at it, we do three different things. One is we create and curate content. We do distribute this digitally and physically, and we also build skills and verify skills. This brings us to this event today. By launching of Conceptual Physics by Professor Paul Hewitt, who is an internationally acclaimed author. This book, this learning experience, has unique. This first edition was launched in 1971, even before I was born. It's been more than 50 years. This content has been widely used because of its common, most unique approach to teach physics to the students. Without taking thunder from Professor Paul Hewitt sharing his thoughts about what he has introduced in this 13th edition, I would like to thank again each one of you to be present here and witnessing the 13th edition launch. Thank you so much.
Thank you, Vinay. Pearson does reckon from my childhood and now to the young bright students that I may see here today. Vinay, country head Pearson India. I'm sure the efforts that Pearson is bringing today will digitally transform the high quality learning content accessible for Indian students. With that, ladies and gentlemen, it is my distinct honor to introduce Mr. Narayana Murthy, a visionary leader and pioneer of the Indian IT industry. As a founder of Infosys, Mr. Murthy has transformed the landscape of technology and has set benchmarks of corporate governance and ethical leadership in India. His journey from humble beginnings to global prominence is an inspiration for many generations. Mr. Murthy is a passionate advocate for education, innovation, and social responsibility. He has dedicated his life to empower individuals and drive positive change through his technology. His contributions have been recognized by numerous prestigious awards nationally and internationally. That includes the prestigious Padma Vibhushan. Can we have a round of applause for Sir present here? And Legion of Honor from France. Today, we are honored to have Mr. Murthy join us on the stage to share his invaluable insight. May I request Vinay to welcome Mr. Murthy formally, founder Infosys, to felicitate him with a token of appreciation. Ladies and gentlemen, it would be surreal to hear from Mr. Murthy himself. Sir, may I request for some words? Thank you, sir.
I was a little bit surprised about the long introduction and the encomiums. Then I realized that the person is not from Infosys, because at Infosys we are not used to it. Anyway. Professor Paul Hewitt, Mr. Chris Balakrishnan is not here. Mr. Dinesh, trustees of the Infosys Science Foundation, Sri Ramaswamy, and other officers of Pearson, India, Ms. Bhavna Mehra, and officers of ISL, guests, and most importantly, children. It is indeed an honor for me to be part of this wonderful event that will hopefully result in making the understanding of physics even more enjoyable, exciting, and rewarding for high school and pre-university students in India. We in India must be thankful to Professor Hewitt and to Pearson India for bringing a top physics book of the latest edition to our high school children. Why is physics important? As the author, Professor Hewitt himself says in the book, and I quote him, "You cannot enjoy a game unless you know its rules. Likewise, you cannot fully appreciate your surroundings until you can understand the rules of nature. Physics is the study of these rules, which show how everything in nature is beautifully connected. So, the main reason why you study physics is to enhance the way you see the physical world," unquote. I must add that knowing these rules will help our children extend the leading edge of physics with new insights to make life so much better for them, for our country, and for the entire human race. Why do I think the book Conceptual Physics is an unusually essential book for every high school student in India? Our Prime Minister has laid out a very aspirational and ambitious target for us, the Indians, to achieve Viksit Bharat, that is, a developed India with harmony and peace by the year 2047. This noble responsibility will be primarily shared by our today's children who are 12 to 16 years old and are in their high school. Indian savants and cognoscenti understand that this target cannot be achieved without making our children sound in scientific and technological learnability and knowledge. An important pillar on which technology stands is, of course, physics. Our journey towards a Viksit Bharat will be smooth and steady if our children develop curiosity about understanding the nature around us, learn critical and analytical thinking, ask deep questions about why the nature is so, become skilled in problem recognition to understand why some natural phenomena do not follow the hitherto known and understood laws of science, and show competence, enthusiasm, and hunger to find solutions to the puzzles behind these natural phenomena that the world has not yet understood. This is how Aryabhatta, Galileo, Copernicus, Newton, Maxwell, Madhava, Niels Bohr, Max Planck, Shushruta, Alan Turing, and Einstein, just to name a few celebrated thinkers, solved some of the seminal mysteries of nature. These new scientific and mathematical ideas led to the creation of zero and the number system, calculus, cars, satellites, radio, television, computers, internet, advanced surgery, transistors, PET scans, lasers, and GPSs, just to name a few great inventions that have made the world a better place. Books like Conceptual Physics can help our children to develop new ideas, to transform our world, and to fulfill the wishes of our Prime Minister. Let me explain how it does. This book explains the basics of physics using examples of phenomena of nature that we come across so often in our daily life, and even some that confound us, like measuring the size of our earth, moon, and sun, measuring the distance from earth to moon and to sun, understand how cable cars work in San Francisco, and how magnetic levitated trains work in Germany. A unique starting point of the book is explaining the scientific method in a simple way, as has been done by the author. I repeat the 5 steps in his own words. 1. Recognize a question or a puzzle as an unexplained fact. 2. Make an educated guess, that is, a hypothesis that might resolve the puzzle. 3. Predict consequences of the hypothesis that you have made. 4. Perform experiments or make calculations to test the predictions. 5. Formulate the simplest general rule that organizes the 3 main ingredients: hypothesis, predicted effects, and experimental findings. The author, Professor Hewitt, tells the children that scientific method is one of inquiry, integrity, and humility. Most importantly, that is willingness to admit error, mistake. He explains that a fact is generally a close agreement among several competent observers who make a series of independent observations about the same phenomenon. He adds that when a hypothesis has been tested repeatedly and has not been contradicted, it has a chance to become a law or a principle. Teachers and students assembled here, please remember this important lesson from Professor Hewitt. Think and rank, think and explain, think and discuss amongst yourselves, and think and solve exercises at the end of each chapter in this book, that is Conceptual Physics, provide a graded path for our high school students to improve their curiosity, critical and analytical thinking, logical questioning, and using mathematical skills to understand the physical phenomena. My fervent desire is that the translations of this monumental book into Hindi, Kannada, and other Indian languages are produced early. This will only happen if our English medium children and teachers embrace the English version enthusiastically, evaluate it, and if found suitable, extol about its excellence to their cohorts and colleagues in the vernacular media. It will only happen if the teachers, the school administrators, and the governments of our states want our vernacular medium students also to benefit from this magnum opus. I congratulate, thank, and salute the author and the publisher for providing a powerful vehicle to enrich the scientific thinking of Indian school-going children at this critical juncture of our society. Thank you very much.
And that's by pacing the course such that it includes all in the class, not just the best and the brightest. It's not a course that we're going to get through. It's a course they're going to get into. And that they're going to get into because physics touches everybody's life. And if you don't want to know about what's going on around you, you're primitive. So physics is yum to course. And I see the people with the happiest faces are the people teaching the physics. Am I right about that?
Yes.
Pity the poor people who don't get a chance to teach physics. Now, when you're teaching physics, again, you want to make your students all feel included. So it's not just the best and the brightest going on to key positions in industry and whatnot. That's part of it. But that should not be the focus. The focus is the little girls and little boys that are kind of struggling to see what life has to offer them and how they can fit in. And they want approval. And if they get the teacher's approval, they feel wonderful. We all feel wonderful when we can do a little bit more than we thought we could. Let me give you an example. You go to the lakeshore and there's people throwing rocks across skipping rocks across the surface of the water. And someone says, oh, there was a guy last week, he got 8 skips. Wow, you got 8 skips? You pick up your little rock nice little flat rock, and you throw it, and ding, 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 9 skips. How do you feel? You feel wonderful. In fact, you'll say, that outing was one of the best days I had in memory. You feel good because you accomplished more than you expected you would. Now, knowing that, look at the power a teacher in any class has with the students. You have the ability to lift their spirits, to make them feel good about themselves. And many will come into a physics course thinking it's going to be very, very difficult, and it's for the best and the brightest, and they'll go along for the ride, and they'll get through the course, and it might be interesting, it might not. No, 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 no. You, teacher, has to change that attitude. This is a course for everybody, even the slowpokes. Everyone's got to feel that this course is about them. Why? They live in the physical world. And as Professor Murthy said, Mr. Murthy said, if you don't understand the rules of the game, you can't appreciate the game. And you can't appreciate life as much as you could as if you understood what's going on around you. How is everything connected? And what are these connections? Why is it sometimes we look up, we see a blue sky. All right, then we look down at later in the day and the sky is red. I wonder if there's any reason for that. Well, yes, there are reasons for that. And understanding those reasons, woo, that makes you're getting educated. You're learning valuable material because you can understand what you see. And that, the physics teacher has the best chance, I think, of all the teachers in school to accomplish that. There are 2 kinds of people I like. I like medical people because they're lifting the health of people. But I like teachers. You know why? Because teachers are lifting their spirits, feeding their brains, getting the students to get the best from their brains. And nothing is more enjoyable than getting the best of your own brain. Or finding you understood an idea that you didn't think you would. You thought, oh, the so-so students should get it, but not me. Baloney. You understand it too. That feels good. This is the kind of course you don't get through. There's a lot of courses where students just have to get through. You get a mark and you go on and it's so-so. No, 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 no. Physics is not that kind of course. Physics is a course to get into, to feel. I like to say it's yum. And so, hooray, you physics teachers doing that. I often think that information is more valued if it answers a question. And that being the case, Mr. Murthy asked, what's the difference between my 13th edition and the 12th edition? And I told him that, well, in the 13th edition, I have many, many more check questions. In my course, it's all questioning, and answering, not in terms of crisp answers, but in terms of ideas. I feel good about that, and I feel good there's so many more in this edition that you have. So when you're teaching the course, pay attention to those questions right in the chapter themselves, and the answers. And then when they have that, then you continue on to the next section. But you want to have some understanding of topics as they flow, not get behind and get overwhelmed. And I'll tell you something I feel really good about. When I heard that this book would be used for high school, I said, oh my goodness, it's going to be too heavy. There's too much information. But I thought it would be for just 1 semester. But hooray, it's going to be for years, a year at a time, but 2 years maybe. Woo! That's nice. You can slow down and really get into it. And that's by the questions. There's another thing that I do in my class. I want to involve the students rather than just sitting passively taking notes or not. And I involve them just like a musical conductor involves all the musicians as he conducts his orchestra. Well, as a teacher, you can be the conductor too. And what you can do is you can ask questions. If you understand this idea, if you really do, then will the force become greater, less, or the same when this happens? Check the person sitting next to you and see what the person says. And I get the students talking in class. I found out that I learned a lot of physics when I was talking about it. And you teachers know this too, that when you're talking physics, and that's what you're doing, you're talking physics, you're learning it more and more at a deeper level, and it's wonderful. No, there's no reason, that's just the way it is. No good. So that's what you do, okay? You look up at the rainbow. The rainbows are completely nice and round, aren't they? They're like circles. In fact, there'd be a complete circle if the ground wasn't in the way. Isn't that right? Now, why is that rainbow round? Someone says, oh, there's no reason for it. That's just the way it is. Rainbows are round. They're beautiful. And you start to explain the physics. And they say, no. Wait a minute. Please leave me my rainbows. I don't want to understand why the rainbows are round and why they disperse these colors. I want it to stay a little mysterious so I can enjoy it. What do I say? I say, wait a minute. Who appreciates music, a musical concert, more? One who is studying music, maybe plays some instruments, or someone who doesn't pay any attention to music at all? Which person enjoys the concert more? The answer is no-brainer. Of course, the person who knows a little bit about it. Who's going to enjoy their lives more? People who just bundle through blah, 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 or people who get in and study every little bit of it and see how much sense it makes and how beautiful it is when you understand it. So your bias as a teacher is that it's good to explain nature, and don't keep it mysterious. Let's solve the mystery and understand it, and that's in that book that you folks have. And you know what? You're going to have fun teaching it. Fun? Is fun a good word for education? Well, fun is finding out that you understand more than you thought you could. So, what I just want to say that I want to thank the Pearson people for being so supportive for this. And they're very, very top-notch people there. And also, let's make it a reality that Mr. Murthy's hopes of lifting the average ability of students across India becomes true. Let's all get behind and help in this effort. It's going to be a good time. You're going to like it. Thank you.
Thank you, Professor Paul. Well done. It is this moment that we've been waiting. Can we have the books handed over to our guests? Will you come here, round of applause? Ladies and gentlemen, a round of applause for the launch of 13th edition of Conceptual Physics, brought to you by Pearson, authored by Professor Paul Hewitt.
Hold it. Just hold the book, hold the book. Sorry, hold it.
Right in the very first few pages, it talks about how the distance to moon was measured long time ago, how distance to sun can be measured, how the size of moon can be measured. I think these are things that children would be so happy to understand. These are things that are not normally discussed in the class. And similarly, explaining Newton's third law of motion. While it says action and reaction are equal and opposite, the ability to actually take real life examples and show where the action is, show where the reaction is, and how it works. I think very, very few people, very few books have been able to do that, and very few teachers have been able to do that. So there were many, many things that in the first several pages that I read were new to me, were new in the sense of tackling the answers, new methodology of coming out with solutions by yourself as well as by team members. I think these are all new ideas, and I think our teachers must encourage our children to use this think and rank, think and discuss, think and solve, etc. These are all very good new ideas. And of course, here's the check questions too. Yeah.